Welcome everybody on behalf of the HE Space team. My name is Barbara ten Berge and I work as a marketing and communication coordinator from the Noordwijk office, the Netherlands. And today we have Mario Tortis, project assurance engineer, who will lead us through what product assurance is, what kind of reviews you do, what kind of objectives there are, and where a PA is involved during a mission or during a project. He will also explain a lot of acronyms you might have encountered, and you will learn something about all these reviews. If you have any questions for Mario, please ask them during the presentations or write them down in the chat so Mario can answer them. The webinar should take up to 30 minutes. And Mario, the floor is yours.
Okay, thank you, Barbara. Thank you. And first of all, I would like to introduce myself. My name is Mario Tortis and I'm a PA engineer. I'm currently involved on META project, which is for weather satellites under the domain of Earth observation. So I hope with today's presentation I can shed some light on this on this position, which I understand cannot be fully clear to those not directly involved in space projects. So let's start with the PA objectives. Our main objective is to make sure that the space project achieve mission objectives in a safe, available, and reliable way. The product doesn't just have to work, but it has to work for the whole mission lifetime. So, as you can imagine, the satellite is not repairable, so we need to avoid the failure in orbit. But actually, even failure on ground during AIT of the satellite can have a huge impact on cost and schedule. So this is why we need to make sure that PA resources are assigned to projects in order to help with preventing these issues. Okay, so PA is a quality function, but we need to clarify that product assurance is not quality assurance. Quality assurance is one of the many PA disciplines. This will be better explained in the next slide. PA is weighted up front in the sense that at the beginning of the project, at the early stage, you need to define the PA requirements and what is the plan to make sure that these requirements are met. QA comes later in the project, it's deployed later, when manufacturing and assembly, integration and test phase starts. In that phase, you need to implement the agreed quality measures and apply the QA process. Next slide. Here we have a description of the PA disciplines, which are basically quality assurance, dependability, safety, EEE components, electrical, electronic, and electromechanical, materials, mechanical parts and processes, and software product assurance. There is also radiation, which is split between EEE and materials, mostly affecting EEE, I believe. And normally on projects, you have dedicated specialists assigned to these disciplines. And as a PA engineer, we need to ensure the integration of these disciplines. You need to interact with all these people and make sure that all issues arising in their domain, they are currently handled. Here we have an example of what we do really on during the 4 project phases. Okay, the first bullet point is regarding the PA requirement, establishing PA requirement and implement the PA plan. We also involved in project reviews. There are several project reviews throughout the project. There are some reviews that are driven by PA, such as review, manufacturing readiness review, and delivery readiness review. For example, the delivery readiness review is the final review before the flight product shipment. And basically, you go through the end item data package and you assess the final compliance of the product and make sure that all non-compliances are closed, all the deviations are agreed, and everything's fine before delivery. Of course, we support the other project reviews that are run, that are driven by engineering. There are always, although they're driven by engineering, there are always PA outputs to be assessed, and there are always PA issues. How do we do our job? Basically, we need to ensure that all the PA disciplines experts are involved in these reviews, that they identify the early issues that may arise, and make sure that any discrepancy and or concerns are found and they are discussed and the way forward is agreed. So we need to make sure that all these experts are involved and we identify issue, and we define the way forward. You have an example of a product review flow. This one, this might change based on product type. This is just an example. So basically, you normally start with the system requirements review, where you establish the requirements. Then you have a preliminary design review, critical design review. Then you get into the manufacturing phase. Manufacturing readiness review is the review that releases the manufacturing of hardware. Then you have the test readiness review, which releases the test. And at the end, at the completion of test, you have the test review board, where you review the results and make sure that all non-compliance are assessed and everything. And the delivery review board is the final review before the delivery, where we make sure that we check that everything has been done properly. We also have PLA control boards, which they have a scope to review triple parts, materials, and process radiation, and these are typically conducted between PDR and MRR. So this normally, before the MRR, you need to get these reviews closed and make sure that all the triple parts, all the materials and process, and the radiation aspects have been properly closed. Okay, the slides describe another important activity in which we are involved, the follow-up of the critical items. What is a critical item? A critical item is basically risk related to quality of the product. Some example can be, for example, whenever you add a new or unqualified materials or process, if you have radiation-sensitive items, if you have any single point failures with severe consequences from dependability and safety perspective. These are examples. For example, these are items for which there is no redundancy foreseen, and if they fail, they can result in severe consequences. For example, for each of these critical items, we need to define mitigation actions. Mitigation action can be, for example, introduction of inspections, double inspection, test. For example, if you have a new material, you need to qualify it. You need to build some testers and vehicles to be subject to environmental testing, such as vibration, thermal cycling, and destructive analysis, depending on what type of item it is, let's say. Another important activity we do is the review and approval of the qualification status. For example, there are, on the space project, there are several types of products that are procured. You might have products that have a consolidated design and heritage, and they are recurring. And there are products that are designed on purpose for the project, or they are new design. And there are also situations in the middle where you have a consolidated design, but it's never been used in that given environment. And the development model depends on this product category. For a newly designed product, for example, you need to build a prototype to be subject to environmental testing, like vibration, shock, thermal vacuum, and EMC, let's say. And so we keep an eye on this. Also, in the case of off-the-shelf products, you have to be very careful, because the product can be recurring, but it can be claimed as recurring. But sometimes, over the years, you might have changes in materials, in suppliers, in processes. Components become obsolete, and they have to replace them. So you need to make sure that any changes, they are properly addressed, because otherwise you can have the consequences can be very severe, let's say. So you really need to be careful in the review of the heritage and qualification. Okay, the last bullet point is related to reporting of major issues. Sometimes you have major issues that need to be reported to project management for resolution. In case there is a dispute with the project, between the project, in that case, we have an independent reporting line to the senior management. And this is a requirement which is in accordance with the ISO standards. I have to say, this is really a last resource. Normally, always try to find the solution, and normally you're dealing with reasonable people. But we have this opportunity, we have this possibility in case of a major issue that can result in a dispute. Okay, then we go to the product assurance control boards. We have basically materials and process control board, parts control board, and radiation control board. These are run by the relevant specialists, and they have the scope. For example, for the MPCB, they have to review materials and processes used within the products, identify if there are any exotic or strange materials, or critical materials, let's say new. In case new materials or unqualified materials are found, they have to define a qualification program. And the parts control board follows a similar process. They need to assess all the parts, the electrical parts used within the product, and for any if the supplier use any non-space qualified parts, they need to agree on lot acceptance testing. They might want to do a pre-cap inspection, DPA at the end on the lot. And of course, there is a discussion of any NCs and alerts affecting the AAA parts. A radiation control board also is focused on radiation aspects. Normally, radiation-sensitive items are electrical components, active components mainly, and some materials. And for these sensitive items sensitive to radiation, they need to define. They need some radiation verification testing, or they need to assess the consequences in case of radiation effect. Okay, this slide is about non-conformance management. This is an activity that requires quite a big effort once you get into the manufacturing phase. You get lots of products to follow up, and non-conformances sometimes arise. Anytime you have non-conformance, the non-conformance management is run by the non-conformance review board. And basically, the first thing you have to do is try to understand the impacts of the NCR, whether you can deal it internally or you need to involve the customer. The NCR investigation root cause analysis, this is also a very important activity because we want to really understand and solve the issue. Of course, the NRB gives disposition, which can be used as is, or rework, repair, scrap, return to supplier. There can be several dispositions. And the NRB is normally composed of the PA engineer, the engineer of the product in subject, and also you might require help from other disciplines, like if you have a non-conformance on a component, you ask for support of the AAA parts engineer, for example. Okay, corrective and preventative action. Yes, of course, we want to eradicate root cause and prevent the reoccurring of the same issue. So this is a very important activity. Alerts management. Okay, here sometimes you have failure or issues affecting the AAA parts, materials, software, which might affect transversally several projects and products. Whenever you have an ISA alert, for example, you need to make sure that the supply chain is aware of it and they are taking the required countermeasures. So this is an important activity that needs to be followed up. Normally, the suppliers, they maintain an alert status list where they have the status of all the applicable alerts and what they are doing to deal with it. Inspection process. Okay, we are involved in inspections. Throughout the projects, we have we always have a mandatory inspection points, which is an inspection point where the customer is involved. These are performed at key steps in manufacturing flow. For example, if you can have a pre-cap inspection before to seal a component, and the component will not be anymore accessible inside. That is a no return point. Or you might want to have a MIP, a mandatory inspection point, on a printed circuit board before the conformal coating is applied, because at that point the solder joint and the components assembly cannot be checked anymore. And basically we are involved in these inspections. Of course, normally they are performed by the materials and process people, but we always provide support as well. We are involved and we also participate. As you can imagine, this activity is strongly impacted by the pandemic, because it is not possible to travel at the moment. So at the moment, we are trying to find other solutions. But of course, reviewing a photograph is not the same as participating in a real inspection. See with your eyes what's going on there. Okay, and next point is regarding audits. Sometimes we are involved in audits. The audits we mainly have on the projects are basically focused on processes like procure, manufacturing. But sometimes our help, they might ask for our help also for QMS audits. Configuration control, yes, this is another activity in which we are involved. Basically, in configuration control boards, we need to make sure that the right experts are reviewing the change in subject. The change can be a contract change notice, can be a request for deviation, request for waiver, and we need to make sure that these are evaluated by the right people with the right expertise. What is a deviation and what is a waiver? A deviation is an authorization to deviate from a requirement prior to start with the manufacturing of the product. So this is an a priori decision. A waiver instead is an authorization to accept a non-conforming product, but you find this out during production. So this is something that is done a posteriori. And of course, we check the as design configuration versus the as built. Okay, what are the main challenges of our role? As you can imagine, on a project team, on a space project, you have lots of actors involved. You need to deal with the project team, with the industry, your counterpart in industries, with partner organization. For example, on Metop SG, we work with the UMETSAT. So you are part of the team. You need to coordinate with them, but being a quality function, we have to be independent. We have to be able to provide an independent judgment. Also, we constantly work under very high schedule pressure. And sometimes, when you realize that the approach that is being proposed is fully driven by schedule, and they are more interested in delivering something in time rather than addressing properly the issue, in that case, you need to speak up. And so this is why we need to maintain our integrity and clarity, even when we work under schedule pressure, because the consequences of a failure can be really severe. Of course, we need to be involved throughout the project life cycle, and we need to ensure that any issues with affecting product quality are identified in time, and they are dealt with by the pertinent expertise with adequate experience. So we need to involve the right people when a problem arises. Another difficulty consists in the fact that on space projects you have lots of suppliers to follow up. You have a supply chain that sometimes is composed of 4 or 5 levels, even more sometimes, and you really have to be able to understand, to have a good judgment of the issues. You really need to focus on the real issue, because if you get involved in each and every discussion, then that doesn't get you anywhere. So you need to really be able to understand where the real issues are. So I think that's it for the presentation. So I hope I'd made some clarity in this role, and of course I'm available to answer any questions.
Mario,
Yes?
It's Keith. Thank you very much. That was really, really helpful, I have to say. I'm just curious, how is the PA engineer seen within the project? Is he seen as part of the team, or is he seen as a kind of annoying policeman, or what? What is your feeling on it?
Well, look, I've been I am fully integrated on my project, and I feel like I'm part of the team. That's it's, of course, sometimes we need to point things out. We need to, as I said before, when you realize that they just focus on schedule, then you need to say, no, sorry, we need to get this sorted. Of course, but normally you work with reasonable people. They understand the importance of our job, and they also. So I never had this kind of issue. I always felt part of the team.
Yeah. Okay.
From this point of view, sometimes there are discussions, of course, as usual, but we always tend to find a solution to problems. It's normally, it's the people I work with, they understand the importance of my job, and sometimes themselves they have it helps having colleagues who have a good quality culture, you know, for sure.
Yeah.
In any case, yeah, they understand why sometimes we get sometimes we raise our points, let's say.
Yeah, I see Marcel is listening in. He's in a similar function to yourself. I wonder if he has any comment on that.
Thanks again for the presentation. What I did realize is that as I'm in human spaceflight, the tasks are a bit different. Not totally, of course, because PA is PA, but some things are different. And to answer Keith's question, yes, in general, you are seen as a part of the team, no problems there. But of course, by the nature of your task, you sometimes are the police officer, as Keith called it. And yeah, that's the way it is. But also luckily, in my case, I never had to go around my project management to go to higher management to get matters solved. Because that's, as Mario also explained, really exception that luckily hardly ever happens. You mainly come to an agreement between yourselves.
So you need to be quite diplomatic, I would imagine.
Yes.
In a sense, yes.
Yeah. You normally tend to find a solution. Normally, it's me too. I never went that way to escalation that way, but there is a possibility, and yeah, that is a requirement from the ISO standards. Yeah. But normally, you tend to find a solution within the project, let's say.
Yeah. Okay. Thanks.
And Mario, one of the questions we had in the beginning was how do you become a PA engineer? So you explained it to me, but maybe you can explain to the others how you started your career as a PA?
No, I didn't. I worked in Thales Selena Space in Italy. I started as a quality inspector. So for me, becoming a PA engineer was a professional growth, let's say. So yeah, it was for career development. So I started in the quality assurance, and I think in quality control, quality assurance, let's say. But it's important. I think it's a good background because you understand the issues. Because you're dealing with the industries, so you need to understand how the industry works, how the industrial environment it looks like, and I think it really helps to have a quality background. Mm-hmm. I would say that candidates for the engineer could be any person who has a strong background in either quality assurance or dependability, safety, triple parts materials in the disciplines, the PA disciplines, which are described in this slide that's showing now. So any person who has a good background in these areas could be a candidate for PA, let's say. But in my case, I come from quality product. I was a quality inspector, let's say.
Mm-hmm. Thank you. Thank you for the presentation. I must say I got a bit of a different view of a product assurance engineer. I noticed that it's a lot more about communication, about trust, about team spirit. And normally, of course, you would do a lot of traveling to customers, and that you need to have a real eye for detail. So I'm quite curious. You said you now might get a photo instead of the real product. How do you deal with these issues at the moment with the pandemic? Is it only photos? Is it videos? Or how did you solve the not being able to travel?
Yeah, at the moment, let's say, yeah, of course, as I said, you know, we contribute to this towards this inspection, but the real inspection is done by the supplier in this case, because you cannot replace a real inspection with a photographic check, for example. That cannot be replaced. But in any case, we contribute toward the supplier inspection by doing this. Doesn't mean that we attend physically because of course we cannot attend physically, and photographic check cannot replace a real inspection. Some suppliers, they have some tools to do videos and sort of things, but really, yeah, it's real inspection is another thing. It's completely different. Okay. At the moment, we are coping with this, you know, and sometimes, yeah, this is what we're doing at the moment. But when it will get back to normal, I think we will be back attending real inspection, traveling, and attending reviews in industry premises. That's many cases face-to-face meetings. They have a lot.
Okay, you get some thank yous from the participants for your presentation. Joaquin, for instance, mentions that it was very helpful for his passive EE component role.